Hello. In this video, I'm going to work through 3 examples of electrophilic aromatic substitution reactions on substituted benzenes. In my first example, I'm reacting acetophenone with bromine in the presence of iron tribromide. In attempting to figure out what the product is going to look like, we need to consider the regiochemical impact of having a certain group on the ring. The main theme of this video is it's about the functional group on the ring. The identity of the electrophile doesn't matter. And so in this case, this acyl group that I've got drawn in the box is a metadirector. It's electron withdrawing by resonance, it's a deactivator, it's a metadirector. And so that means the major product of this reaction, we're expecting the bromine to end up on the meta position. We need to resist the urge to draw bromine ortho or para. While bromine is an ortho-para director, it's not there already. The directing group comes from the functional group already on the ring. Now I have ethyl benzene reacting with acetyl chloride and aluminum trichloride. We have a functional group already on the ring. Alkyl group. Alkyl groups are ortho-para directors. And as I shared in the previous video, para tends to predominate over ortho for steric reasons. And so now we get this para-ethyl acetophenone. And again, resist the urge to think too hard about the identity of the electrophile. The electrophile tells you which functional group you're going to add. The directing group on the ring tells you where it's going to go. And then I couldn't help but finish up with a trick. You might look at aniline and say, haha, the amine is an ortho-para group, right? This is an ortho-para director. You might be surprised to learn that this reaction, while the yield particularly isn't very good to begin with, this reaction generates a fair amount of meta-nitroaniline. And the thing that I just wanted to do in this exercise, though, was to remind you that functional groups do also have other behaviors. And the amine functional group is also a base, and we're subjecting it to acidic conditions. And so it's going to get protonated, and now we've got this thing here, and this is a metadirector. And that's why we get meta-nitroaniline and not para or ortho-nitroaniline. I'm going to wrap up down here by putting in my 2 main thoughts, and that is the electrophile controls the functional group being added. The directing group on the ring controls the location where the reaction occurs. If you can keep those 2 things in your head when you're thinking about these reactions, you'll do pretty well. This wraps up the video sequence on substituent effects, though there's more to be said about molecules that have multiple substituents. I'm holding on to that to a sequence of videos on synthesis applications of aromatic substitution. Thank you for watching.